Here's the first one you sent me. It says at a stop sign, some drivers come to a full stop, some come to a rolling stop, some don't stop at all. We would like to test if there's an association between gender and the type of stop. We collect data, yada, yada, yada. If gender is not associated with the type of stop. So if these two things are not related, how many males would we expect to not stop at all? So this is our observed data. I'm looking for the expected data. If they're not related, the expected data, they're independent. So I'm going to start by putting this matrix into my calculator. Second matrix, I'm going to edit. Hold on, let me clear this out first. Memories, 7. Memories, I'm going to do 7, 1, 2. There we go. Matrix, over to edit. I have 3 rows and 2 columns. I'm going to put my observed values into there. Observed, 6, 6, 16, 15, 4, and 3. Now I'm going to run my chi-squared test so I can get my expected values into B. I don't have to do any math now. So I don't care about that right now. So I'm going to go back to my matrix, and I can either select it, hit enter. Oh, that's perfect right there. So I'm looking for the cell that's associated with men or males not stopping. If they were not associated with, if gender was not associated with the type of stop, we would expect how many males to not stop at all? Males to not stop at all. That's the bottom left cell. This is going to be 3.64. Okay. This one here, the researchers studied the link between prenatal vitamin use and autism, surveyed the mothers of a random sample of children with autism, and conducted another separate random sample for children with typical development. The table below shows the number of mothers in each group who did and did not use prenatal vitamins during the 3 months before pregnancy, yada, yada, yada. State the appropriate hypotheses to test for independence of use of prenatal vitamins during the 3 months before pregnancy. So we're basically showing that we're not showing that the use of vitamins makes things, the development, less or better or worse. So it's not going to be these two. We're just trying to show that they're not the same. Right? That's all you can really tell with a test for independence, is that two things are not associated, not the same. Okay? So we're just going to start by putting this. Don't ignore the totals. We don't need that. Put that 2 by 2 matrix into your calculator. So let's see, I can go back to matrix. Let's see if I can just edit this one, make it 2 by 2. And I get 111, 70, 143, and 159. Now we're going to run our test again. I think this should replace it properly. Let's see. Expected, yada, yada, yada. Yep. So the computer is actually wrong. Their test statistic is wrong. They have like 2.98 or 2.89, something like that. That's wrong. Their test statistic is going to be 8.865. 8.86. That's a typo on their part. The p-value associated with it is 0.0029 or 0.003. Even to 4 places is 0.003. So the p is low, is lower than alpha. When the p is low, we reject HO. P is low, reject HO. So since p is less than alpha, we reject the null. Let's see here. Since p is, we fail to reject the null? No. We're going to reject the null. Since p is out greater than alpha? Nope, nope, nope. There's our answer right there. P is lower than alpha. We reject the null and accept the alternative, that they're not equal. Okay. You intend to conduct a goodness of fit test for multinomial distribution with 6 categories. Degrees of freedom is always equal to the number of categories minus 1. So if you have 6 categories, this is just going to be degrees of freedom is 5. That's it. That's from the notes, the PowerPoint notes. Okay. In this one, you're conducting a test of homogeneity for the claim that 2 different populations have the same proportions of the following 2 characteristics. Here's the sample data. So back to our matrix menu. Edit A. Let's do this. This is going to be 39, 69, 68, 34, 61. Stat back to our test menu. We're going to go to our chi-squared test. Observed A is going to expect it's going to go into B. We have everything we need. Our chi-squared test statistic is going to be 0.9225. Degrees of freedom. If there's two categories, boom, boom. Degrees of freedom is going to be one less than that. 2 minus 1 is 1. What's the p-value for this? That is 0.009. I'm sorry, I switched these. That's my mistake. Oops, let's get the eraser going here. Our test statistic is 0.0095. Come on now. And our p-value is to 4 decimal places is going to be 0.9224. Basically, you could say 1, or you can leave it as 0.922. Actually, that'll round up to 5. So this would be 0.9225. Basically 1. The p-value is greater than alpha. So we fail to reject the null because p is higher than alpha. Okay. Fail to reject the null. There's not sufficient evidence to support the claim of the alternative. I can't see the bottom. I don't think it's either one of these. I can't see the bottom. Hang on one second. I'm going to try and pull it up. So here's the problem itself. Okay. There's not sufficient evidence to warrant the rejection of the claim. This is the null, that the two different populations have the same proportion. So your answer is going to be right here. This is the null hypothesis. There's not sufficient evidence to reject it. We fail to reject the null. So that's going to be option 3. And the last one, sorry about that, is the Gallup poll released in December 2010 asks 1,019 adults living in the United States about their beliefs in the origins of humans. These results, yada, 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 boom, boom, boom. Okay, it says state the hypothesis for the following research question. Have beliefs on the origin of life changed since 2001? So we're saying the population in 2010, we're going to assume it follows 2001. We're trying to show that it actually, in fact, changed. So we want to show that the population follows. So this is saying population follows. No, we're talking about 2010. So we're saying the population follows 2001 distribution, or the population does not follow. This just doesn't make sense. So we're assuming that it follows, trying to show that it doesn't. So our null is that it follows this distribution. We're assuming that we're trying to show that it doesn't. Okay. So this says calculate the actual number of respondents in 2010 that fall into each response category, as well as the expected number, assuming that the null is true, assuming that it follows the 2001 distribution. So we're just going to take these percentages and multiply them by 1,019 adults. So I'm going to write 1,019 and just figure out what these percentages are. So I have 0.38 times 1,019. I'll do 0.16 times 1,019. 0.4 times 1,019. Let me copy those down. 387.22. I'll round to the nearest whole number, so this would be 387. This will be 163 and 408. 163, 408. And then the last one is 6%. 0.06 times 1019. 61. Well, that's the actual observed, but now I'm looking at the expected. If it follows the same distribution as 2001, the expected values would be, I'm going to take these percentages and multiply them by 10,019, or 1,019. 0.37 times 1,019. 0.12 times 1,019. 0.45 times 1,019. So I have 377, 122. 459. And the last percentage is 6%, 0.06. That's probably the same as the other one, right? Yep, 61. So now I want to compare these two groups, an observed list and an expected list. When you have lists, not a matrix, I want to go put them in my stat menu. Edit. I'm going to put the observed in the left side 387, 163, 408, 61. Right side 377, 122, 459, 61. Now, instead of the chi-squared test, I'm going to do the chi-squared goodness of fit test because I'm talking about lists. Observed list is L1. Expected list is L2. Degrees of freedom. How many categories do I have? I have 4 categories, so I'm going to have 3 degrees of freedom. Calculate, and I got all my information right there. Test statistic is 19.71. Degrees of freedom are, we said 3. P-value is 1.9487 times e to the negative 4. So that's 0.00, 0.00019, or it's 0.0002. Don't forget the scientific notation. Okay, so your P is very low. Your P is going to be less than alpha. So you're going to reject HO, accept the alternative, HA, which I don't know what they are. I can't see them on this this example. But there's your answer.